Okay, so basically this is going to serve as an overview of what we talked about in lecture one. The first thing that we talked about was the difference between a parameter and a statistic. And I'm not going to read the definition to you because you can do that, but I do want to give examples of each type. So let's say that you have 10 people who live in your household, and that includes you, and you would like to know the average weight for your household. And you want the best average you can get. So what do? Well, you're going to have everyone in the household, including yourself, to get on the scales and weigh in, and you're going to record the 10 weights. You'll add those up and divide by 10, and you have the average. You have the true average because you have weighed everyone. Everyone in the household was included in the process. So let's say that you figure out that the average in your house is 200 pounds. Well, not only is that the average, but it's a parameter because everyone was involved and you have a perfect result. Now, suppose one person is not present. Let's say that your brother happens to be working and you want to go ahead and try to figure out the average weight. So you just end up getting 9 weights because brother's not there. So you take the 9 weights and you add those up and divide by 9 and you say, well, this is the best I can do. It looks like the average weight is 195. Well, since the brother was not included, we are now 5 points less than the true weight, the true average weight. So that 190 is really a statistic. It's a statistic that we are using to estimate the parameter. The parameter happens to be 200 because that's what the number would be, the average would be, if everyone participated. But since brother is not present, or if brother is not present, then the 190 would simply be a statistic. A statistic is weaker than the parameter. The parameter is always considered to be perfect if everyone can participate and give you the data that you need. But if you have to estimate by using a sample, then you would call that result a statistic. We also discussed sampling methods, and I just want to give an example of each of these. Suppose you are, let's say that you are a principal at a comprehensive high school, and you would like to know who the students would like to elect for Teacher of the Year. And you want to use systematic sampling. So you may ask your computer, or maybe you have an app on your phone that can generate random numbers, and you tell it to generate a random number between 1 and 20. And let's say that the random number generator happens to give you 13. So as principal, you will go out in the hallway, and every 13th student who comes by, you will ask them, hey, who would you like to see nominated for Teacher of the Year? So once that student gives you his or her answer, you go to the next 13th person, which would be the 26th person you encounter, and you ask that person, hey, who would you like to have as Teacher of the Year? And then you will count off another 13, and you will ask them the same question. And you would do every 13th person until you have completed your study, and you would take that information to see who the most popular person is, who the choice is for Teacher of the Year. So that's systematic sampling. Convenient sampling would work this way. Let's say that you're principal and you happen to be in the parking lot on the east side, and you walk up to about 30 students as they're going to class, and you say, hey, which teacher would you like to nominate for Teacher of the Year? And so you get your information from them. That's convenient because you happen to be in the area where those students were. So that's convenient sampling. Then we have stratified sampling. So stratified sampling might work this way. Suppose you divide all of your students into 4 groups: freshman, sophomore, junior, senior. And you have a list printed out, right? You have a list of all of your freshmen, a list of all of your sophomores, a list of your juniors, and then seniors. And then you randomly choose 20 students in each class. And you ask those 20 students who they would like to nominate for Teacher of the Year. So when you finish, you would actually have 80 pieces of data, right? You would have 20 students from each class, the freshman class, the sophomore class, and so on. So that is stratified. And the advantage to stratified is that you go across the whole spectrum of the school, right? The freshmen get a say-so, the sophomores have a say-so, and so on. Cluster sampling, in my opinion, is a little more difficult. So what you would have to do in this case as principal is you would still have the freshman, sophomore, and junior and senior classes divided up, but you're only going to choose, let's say, 2, okay? So let's say you happen to randomly pick freshmen and seniors. Well, once you do that, then you would have to go in and ask every freshman and every senior who they would like to nominate for Teacher of the Year. So stratified gives you the chance to sample from all student populations or groups. Cluster allows you to narrow the groups down to a fewer number, but the downside with cluster is that you have to go into each of those that you choose and survey or sample everyone. A few things to be aware of. One thing to be aware of especially is the voluntary response sample, because they are usually emotionally charged. Let me give you an example. Let's say you are on a date at a restaurant and the meal is great and the service is great, and at the last minute, let's say the waiter spills coffee on your pants and you become infuriated and you ask to fill out a comment card and you just give that restaurant terrible ratings. Well, we know that you were enjoying the entire experience, right? Up until the last minute when the waiter spills the coffee. So your comments on the card really do not accurately reflect your evening at that restaurant. They reflect that you were angry. So voluntary response surveys, again, typically not valid because they're full of emotion rather than facts. If you are doing studies, a few things to think about. I'm going to point out just a couple on the list here under analyzing pitfalls. Try to avoid jumping to conclusions with your data. For example, if you happen to survey 50 MTSU males randomly and you ask them for their weights and you find out that the average weight is 175, well, that's really all you know. Don't jump to conclusions and say things like, well, MTSU students must eat well or they must exercise regularly, because you really don't know that. So once you get your data, look at what the data really tells you and do not try to run amok with it. Do not try to reach conclusions that are really not there. Reporting the results. If you're going to weigh somebody, I would say if you want to know someone's weight, you would need to do that yourself. A lot of times people would tend to lie about their age or their weight. So if you're going to try to gather information that is somewhat sensitive, you might want to look at a driver's license photo in order to get the true age, or you may want to just weigh the participants yourself so that you know that your data is solid. Also, be careful with small samples. You wouldn't want to weigh 5 students at MTSU and draw conclusions based on those 5. Loaded questions are also dangerous. Let me give you an example of a loaded question. Do you still beat your wife? Well, if you say no, then that indicates that you used to, but you no longer do. And of course, if you say yes, well, that's not good. So how do you answer a question like that? That's considered a loaded question. And if you're going to survey people, you want people to trust you. And if you are coming at people with questions that are loaded and make them feel sort of pinned in so that they have to either incriminate themselves or answer dishonestly, you're not going to get good valid data that way. Watch the order of your questions. If you want to know whether a person is a Republican or a Democrat or a liberal or a conservative or a Christian or an atheist, anything that's, I guess, emotionally charged, you might want to ask those questions near the end of your survey, because if you put those questions at the beginning, it's not a good way to start off the conversation, and the participant may decide to close off and not give you good, honest reporting. Good, honest data, rather. Also, be accurate in your numbers and in your percentages. If you decide to use charts, make sure that the charts do not distort the data. Oftentimes, newspapers will use artwork and charts to sort of mislead the audience. They know that a lot of people will not read the article to get the numbers. They'll just look at the charts. And sometimes they make the charts, bigger, fatter, different colors to sort of manipulate people. So when you use charts for reporting, make sure that the charts do not distort the true findings. We talked about data types. We put the data types into two categories generally. One category talks about, well, is the data type quantitative or qualitative? If you're going to be performing mathematics on the numbers, then you have quantitative data. If you're not going to be performing mathematics on the numbers, then you have qualitative data. So quantitative data would be things like age, height, weight, because you would want to maybe add those up, right? And divide and so forth. Maybe you want to know an average height or an average weight or an average IQ. That would be quantitative data. Qualitative data, again, we're not doing mathematical computation. So football team jersey numbers, for example. We do not take jersey numbers and add those up and square root those, multiply those together to come to any meaningful conclusion. The jersey number is there just to sort of identify who the players are. Same thing with driver's license numbers and social security numbers. We're not going to add those up and subtract because there's no real mathematical purpose in doing that. So make sure you're familiar with the difference between quantitative data and qualitative data, and then continuous versus discrete data. If data is continuous, then you have no gaps as you go from one number to the next. It's just a smooth stream. Think about filling up a swimming pool full of water, right? 1 gallon doesn't plop in and then another gallon suddenly fall in, right? It's just one continuous movement as the water begins to fill up the pool, right? So volume of water, temperature, height, weight, all of those types of things are continuous. Discrete data has gaps. For example, if you're counting the number of people at Bonnaroo, those are distinguished among themselves, right? There are gaps there. You can actually, you know where one person ends and another person begins. You can actually count them. Think about maybe counting M&Ms in a bag, right? You would take those out and you could actually pick them up one by one and count those. So if you can count them and there are gaps in between them, so to speak, you have discrete data. Otherwise, if it's continuous, right, no gaps, then you have the continuous data. So what about a pool repairman, right? He wants to know the amount of water in the pool. That's going to be quantitative, right? Because you can figure out, you can add the number of gallons of water in the pool, right? You can figure out the average gallons of water for a pool, and you can perform mathematics on those numbers. Also, the data is continuous, right? Because the water flows in, no gaps, so to speak. So that's going to be quantitative and continuous. A carnival goer tries to estimate the number of jelly beans. Well, okay, well, the jelly beans are going to be quantitative because we're counting those. And they are discrete, right? Because we can actually separate the jelly beans out. What about a nurse recording the temperature of male athletes? Well, that's going to be a quantitative measurement because we could figure out the average temperature, right, for the football team. We could actually take the temperatures of all of the players and we could average those together. And so that's going to be quantitative. And we know that it's continuous because temperatures do not jump from one number to the next. You do not go from 94 degrees automatically to 95 degrees. You have to pass a whole spectrum of numbers. So for the nurse, that's going to be quantitative and continuous. What about a football coach recording the time that it takes for an athlete to run 100 yards? Well, time is going to be, in this instance, it's going to be quantitative because maybe the coach wants to know the average time for his team. So he can do mathematics on the times, but time is also continuous, right? Because there are no gaps between 1 second and 10 seconds, right? There's a whole stream of numbers actually in between. A soccer coach is recording the number of goals scored by each player. Well, he can count those goals, right? He can do an average number of goals scored. So that would make that quantitative. But in the other category, we have discrete data, right? Because the goals are separated out. We can actually separate them out and we can count them separately. We know where one goal ends and another one begins. And then we have an engineer for Bridgestone. He's trying to determine the average mileage for the cheapest tire. So he's doing mileage. He wants the average, which means he's going to be performing some mathematics there. That's going to be quantitative. And figuring out distance is going to be continuous, because you do not go from 1 mile to 2 miles automatically. You have to pass through an entire stream of numbers. There's a whole spectrum there, so that's going to be continuous. What about the coach documenting each player's jersey number? We've already talked about that. The jersey number is going to be qualitative. We're not going to be doing math on jersey numbers. We're going to use those just to identify who the players are. So again, that would be qualitative and discrete, because we know where one jersey number ends and another one begins. There are gaps there. Then we have levels of measurement. We have the ratio, the interval, the ordinal, and the nominal. The first two are going to be quantitative in nature. We will actually do some mathematics on those. And a level of measurement is ratio if there's a natural zero. For example, if I caught you cheating on a test and I gave you a 0, that would be because that's as low as I can go. I'm not going to be able to give you a negative grade, but I can give you a 0. If you lose weight and continue to lose weight, or if you shrink in height and continue to shrink, you are going to get closer and closer to a natural number called 0. You're not going to go any lower. So numeric grades, weight, height, those bottom out at a natural 0, so those are called ratio. Interval data values can actually go lower than 0, and temperature is a good example. For example, it could be 5 degrees below 0. Right? 3 below 0, you're below 0, so that would be considered interval measurement. Ordinal means you can put the data into a meaningful order. Let's talk about letter grades. I know that I would rather have an A than a D, but I would rather have a D than an F, which means I can take those letter grades and I can put them in an order that's meaningful. In other words, some are better than the others, for example. Same thing with Olympic medals. If given the choice, most of us would prefer the gold over the silver, and we would prefer the silver over the bronze, because there's an order there, and those orders do have meaning. And then we have nominal data. Nominal is just for identification purposes only. What is your eye color? What is your zip code? What is your football jersey number? What is your zodiac sign? Those things are just categorical for identification purposes only. So the top two, ratio and interval, they're quantitative. And then the bottom two, ordinal and nominal, are qualitative. The last thing we talked about was observational versus experiment. If you're doing an observational study, then you are not going to do anything to manipulate the participants. For example, if you go to a, let's say a local airport, and you notice that one of the bathrooms is closed, there's a sign across the door, out of order. And you want to know, how are people going to respond to this? Are they going to become angry? Are they going to go in there and use the bathroom anyway? Or are they going to just casually go to the next available bathroom? So you just take a seat and you take out maybe a notebook. You just kind of jot down the information, or maybe you record the participants. They don't really know you're there, and you're not doing anything to manipulate them. That's observation. An experiment means that you actually did something to manipulate some of your participants. For example, let's say that let's say you're a pharmaceutical rep and you're trying to convince a doctor that she needs to purchase a particular drug, or let's say, I don't know, pain remedy. And you tell the doctor, you know, we've actually done some studies on this drug, and we took 100 participants and we gave 50 of them the drug, and the other 50 we did not give the drug to, and then we monitored them for 30 days. Well, that's an experiment, because you actually manipulated the participants. You actually drugged half of the participants. So make sure you understand the difference between observational, which means you did not really participate directly, versus an experiment where you actually had some sort of an interaction with some of the participants. That pretty much concludes what we talked about in lecture 1, and I look forward to seeing you next week. Thank you.